Hello, my name is Sunju Lee from the Postdocs Computer Science and Engineering Department. I will proceed in my final report from our research regarding graph classification. The objective of this research was firstly to understand the basics of graph classification along with other related fields such as machine learning and computer vision. Along with the technique, the application possibility and importance in research of this area was also subject of interest. As written below, since the research basis itself on the ADNI dataset or cerebral data regarding Alzheimer's disease, this research focuses mainly on the medical applications of graph vision. The reasons behind choosing such topic of research is also based on such issues. Medical data, since must be manually labeled by medical professionals, are small in size and generally noisy, as comprehension depends solely on the ability of the examiner. Graph classification tasks must understand such limitations while showing strong classifier capabilities. Unlike mentioned during the progress report, the research will be focusing solely on GCN, short for Graph Convolutional Network. Other models were also scrutinized, however most models were excessively complex or deep regarding the constituting layers, which made it inadequate for this dataset. Implementations of GCN were based on stellar graphs, machine learning library, PyTorch keras, and semi-supervised classification with Graph Convolutional Network, research thesis by Thomas N. Kiff and Max Welling. Specifications regarding model is included in the next slide. The main difference from GCN and other CNN models is the graph convolutional layer. Like other data, graph data cannot be adequately mapped to the Euclidean domain, thus requires conversions. Previously, this conversion relied heavily on Fourier transformation. However, according to the previously mentioned research thesis, nowadays spectral wavelet approximation theory suggested by Hammond is utilized to achieve fast, approximate convolutions. Details regarding the dimensions and structure of the model are as shown on this slide. This research will be focusing on datasets with the following characteristics. The dataset will consist of brain network graph data obtained by DTI or Diffusion Tensor imaging. It was collected from 120 individuals in the interval of 2 years, such that the data can be obtained distinctly or as 120 spatiotemporal data. Each node represents a neural region, and each edge represents the number of neural fiber tracks between each neural regions. The graph's labels are HC, EMCI, LMCI, SMC, and AD. To summarize, there are 500 graph data with labels and node features within this dataset. The dataset provides FDT adjacency matrix and node features, so conversions to stellar graph objects are necessary for this model to actually work. During this conversion, edges between the same nodes were averaged, and edges with weight of 0 were dropped. Afterwards, the edge weights were normalized due to its large range. Among 5 labels, only C, N, and AD were selected and others were dropped during the training session. The training of the model yielded the following results. Please notice that the linear validation accuracy and the fact that the mean accuracy of the field were 65.7%, which is only slightly higher than 58.9%, which is the ratio of CN labels in this dataset. Due to such qualities, the model is highly susceptible to the only predicting single class without properly learning or updating any parameters. During this research period, many endeavors were attempted to fix such errors. However, due to the lack of time, this was not fully achieved. Instead, reasons of errors were analyzed so that the research can carry on after this report. Among the reasons mentioned, the highly possible is the failure in data pre-processing and error in the model itself. However, due to the lack of expertise in both fields, these errors were not amended during the research periods. Therefore, regarding such errors identified from the previous slides, the following improvements are to be made regarding this research topic. Thank you for all your time and effort.